Hello and welcome to this lesson on the camera and camera APIs in Android. In this lesson we'll cover some of the characteristics, properties, and APIs for cameras on Android devices, and how to utilize them in your applications. The camera component in Android has a wide array of possible configurations and properties, which may or may not be present in any given device. The hardware configurations can contain options like a front-facing or back-facing camera capability. Also, capabilities like frame rate and autofocus can be found in the hardware configurations for a camera. In general, cameras in Android are classified to a hardware level. These hardware levels classify the overall set of the camera device functionality. Camera devices will come in three flavors: Legacy, Limited, and Full. Full devices will support capabilities like manual sensor control, manual post-processing control, arbitrary cropping, at least 3 process but not stalling format outputs, and many more capabilities. A limited device, on the other hand, may have some or none of the previous characteristics. Some features are not part of any particular hardware level or capability and must be queried separately. These can include calibrated timestamps, precision lens control, face detection, optical or electrical image stabilization, and more. A legacy device does not support per-frame control, manual sensor control, manual post-processing, arbitrary cropping regions, and has relaxed performance constraints. Each higher level supports everything the lower level supports, in this order: first full, and then limited, and finally legacy. In addition, the hardware configuration will contain information about the camera features, like illumination capabilities and lens focus capabilities. Camera hardware is a shared resource that must be carefully managed so your application does not collide with other applications that may also want to use the camera feature. Remember to release the camera object by calling the camera.release method when your application is done using it. If your application does not properly release the camera, all subsequent attempts to access the camera, including those by your own application, will fail, and it may cause your application or other applications to be shut down. Android devices can have multiple cameras. For example, a back-facing camera for photography and a front-facing camera for video calls. Android 2.3, API Level 9, and later allow you to check the number of cameras available on a device by using the camera get number of cameras method. If you have determined that the device on which your application is running has a camera, you must request to access it by getting an instance of the camera, unless you are using an intent to access the camera. You can access and obtain an instance of the camera by calling the camera.open method. Once you obtain access to a camera, you can get further information about its capabilities using the camera.getParameters method and checking the returned camera.parameters object for support capabilities. When using API level 9 or higher, using the camera.getCameraInfo method to determine if a camera is on the front or back of the device and the orientation of the image. Here we have an example in code of how to detect if there is an available camera on a device. In this method, the checkCameraHardware method, which receives context as a parameter, we will need to use that context later for obtaining the package manager. We obtain the package manager by calling the getPackageManager method on the context which we have received as a parameter. We can then query the package manager for specific system features by calling the hasSystemFeature method. In this case, we can call the hasSystemFeature method with a constant parameter package-manager-feature-camera. This will return true if the system has at least one camera feature, and false if no camera is available. In this code example, we gain access to a camera after verifying the system has the camera feature. We create a new camera instance and initialize it with a static method camera.open. Note that the method call for camera.open is surrounded with a try and catch block. Always check for exceptions when using camera.open. Failing to check for exceptions if the camera is in use or does not exist will cause your application to be shut down by the system. On devices running Android 2.3, API level 9 or higher, you can access specific cameras by using the camera.open method with the parameter of an integer. This integer will notify which camera we are requesting. The example code above will access the first back-facing camera on a device if more than one camera exists. Once the camera is opened, or not in the case of an error, we will return the camera, or a null pointer in the case that no camera was opened, back to the calling method that called the getCameraInstance method we have here. For users to effectively take pictures or video, they must be able to see what the device camera sees. A camera preview class is a surface view that can display the image data coming from a camera, so users can frame and capture a picture or video. This view can then be embedded in a layout for any screen of your application, just as any other view would be connected to your layouts. In addition to the camera preview, it is common to add controls or other UI interactive elements to allow the user to perform specific actions based upon the camera preview. For instance, if you're making a party picture application, you may add a button that will cause the camera to take a picture that is saved to an album for the party. Special visual and sound effects can be added to these operations when needed to enhance the experience. Here we have an example of how to create a camera preview in Android code. We've created a class called Camera Preview, which extends the Surface View class and implements a SurfaceHolder.callback. We have two members, the Surface Holder and a camera object. We receive context and a camera object in our constructor for this class, and we store the camera object in our member, and we also get the holder for this class and add a callback of this class. When we receive the callback for Surface Created, we initialize and start the preview for the camera by setting the preview surface to this class and then starting the preview. Note again that this call is within a try and catch block to ensure if an exception is thrown, it is caught here, and an error message is displayed. In the Surface Destroyed callback, we do nothing in this example, but this is where we should take care of releasing the camera preview in our activity. In this last section of the example, we have the callback for Surface Changed. In the case that our preview should be rotated or changed based on surface changes, we should implement those differences and changes here. It is very important to stop the camera preview before resizing or rotating, which we can have the ability to do here. Once the camera preview is stopped, we see that we have a comment for the area to perform any resizes, rotations, or other reformatting changes before restarting the preview. Once those changes are completed, we reset the preview display to the holder for this instance and then restart the preview. Just as easily as we've seen here, we can add a preview of the camera on a device to our application. Again, note that this class is a derivation of the Surface View, and as a view class can be inserted and manipulated and used in a similar fashion to other views. Note that in this example, the class requires a camera instance in its constructor, so it could not be simply declared in the XML for a layout, but that can be changed very easily to receive the camera instance in another fashion, so that can be declared as other views are declared in layout XMLs of an activity or another component. In order to retrieve a picture, use the camera takePicture method. This method takes three parameters in order to receive data from the camera. In order to receive data in a JPEG format, you must implement a camera picture callback interface to receive the image data and write it to a file. Video capture using the Android framework requires careful management of the camera object and coordination with the media recorder class. When recording video with the camera, you must manage the camera lock and camera unlock calls to allow the media recorder access to the camera hardware, in addition to the camera open and camera release calls. Starting with Android 4.0 API level 14, the camera lock and camera unlock calls are managed for you automatically. Unlike taking pictures with the device camera, capturing video requires a very particular call order. You must follow a specific order of execution to successfully prepare for and capture video with your application. That order consists of opening the camera, connecting the preview, starting the preview, start recording video, stop recording video, stopping the preview, and finally releasing the camera. Here we have an example of how to create and prepare a media recorder for recording video in application. First, we need to obtain the camera instance, then create a new media recorder instance. The first step is to unlock the camera and set the camera to the media recorder. Then in the second step, we need to set the sources for the media recorder. In the third step, we need to set the camcorder profile. Note this requires API level 8 and above. In step 4, we configure and set our output file for this recording. In the fifth step, we can set up our preview for the recording. And finally, in our sixth step, we prepare the media recorder. In case of an exception, we release the media recorder. Once the media recorder is prepared, we can start recording by calling the start method on the media recorder. Note that we have to ensure that the recorder is released properly by calling the release method. As previously mentioned, cameras are a resource that is shared by applications on the device. Your application can make use of the camera after getting an instance of the camera, but you must be particularly careful to release the camera object when your application stops using it, and as soon as your application is paused as well. If your application does not properly release the camera, all subsequent attempts to access the camera, including those by your own application, will fail and cause your application or other applications to shut down. Here in this example, we show how to properly release a camera and also release a media recorder. In the onPause method callback of the activity, we ensure that all media recorders and cameras are released for this activity before moving it to the background. Note that in the method releaseMediaRecorder, we ensure that the media recorder instance is not null, and then we call the reset and release methods on it. Once it is released, we call the release camera, and after verifying the camera instance is also not null, we release the camera so this application and other applications can then reuse the camera in the future. Thank you for joining us in this lesson on cameras and the camera APIs in Android. Join us in our next lesson where we will cover audio and video in Android development.